All right. Good morning, everybody. How are you? All right. So let's take a look at these announcements. For Sunday, we're going to be back in the normal classroom, our original well, not the original location, because if you remember, at the very first of the semester, we were on the first floor. So we'll be back upstairs on Sunday. And then homework 5 is due on Sunday as well, and that includes some stuff on the spreadsheets. So I'd encourage you, as always, to get an early start on the work. The nice thing about the videos is that you can watch those over and over again and see exactly what keystroke I did, and you can follow the illustrations that are on the recordings. I hope that helps. But at the same time, my office hours are this afternoon. I'd also be willing to write emails to you over the weekend. So if you run into trouble, please let me know. I want to help you out. So today we're going to do some more with spreadsheet functions and then also dealing with complex cash flow diagrams. Before we get into the new material, do you have any questions related to the announcements? All right. So here's an annual series and also a single random amount. And what we need to do is find the present equivalent of these amounts. So we would need to know, if we're going to be making these payments in the future, how much should we receive today in order to justify those future payments? We know from the cash flow diagram that the interest rate is 10%, and you can see that there's an annual series of 5,000 and then the single amount is 2,000. So let's just look at sort of the procedure we'd use to bring all of this money to year 0. We separate the two components. We separate the single F value and the A, and so you apply the uniform series procedure to the series, single amount formulas to the one-time cash flow, and then combine them together at year 0. So here's the illustration. What we do is you can see it's renumbering below the axis there. And that renumbering is sort of like we're going to treat year 2 as though it's year 0. So we know that in reality, from the perspective of where we want to take the money in the end, that year 2 is year 2, but in the perspective of where this annual series is, we know that the payments begin in year 1 of an annual series. And so our first step is going to move from year 3 to year 2 by pretending that year 2 is actually 0 in the context of the annual series. And so that's why these have been sort of relabeled with a series year underneath the actual year. Any questions about that? Why we're renumbering the years? We're doing that so that when we take we have a limited number of tools available. And we don't have a tool, there isn't a factor that allows us to take the annual series straight to year 0, as it's shown in the top cash flow diagram. That's not the pattern of an annual series. An annual series, the pattern of it is that there's year 0, and then in the first year, the uniform payments begin, where here's 1, 2, 3, 4. So since this is the pattern of a uniform series, what we have to do is convert this to an amount here. And that year before the payments actually begin is here at 2. And so we're going to convert the annual series to something at year 2, and then we're going to move it from year 2 to year 0. They've labeled in the lower graph the series years. And so you can see that the new reference point that we're using in our intermediate step has been labeled. With renumbered the cash flow diagram so that the first payment in the annual series was in year 1, and so the year before the first payment we label as year 0. Other questions about that? All right, so the result of that is that we are taking the amounts to year 2, and here's the calculations you can see for that. We're doing a P/A function, so we can look up the factor in the back of the book. P/A means find the present value of an annual series. The interest rate is 10%, and n equals 8. So if you go to the factor table for that, you'll find the factor table gives you 5.3349. Multiply that by the annual amount. So this 26,275 is in year 0. And we need to shift it another 2 years to get it to, well, it's in year 0 from the perspective of here. But in reality, the actual year is year 2. So then that's when we do this last step, is moving it from actual year 2 to actual year 0. So that's a single amount now. This 26,675 is a single amount in year 2, and we need to move it to year 0. So we look up the P/F. So we're treating this amount in year 2 as a future amount, and we want to find the present equivalent of that. So the discounting factor is 0.8264 when you're moving something back 2 years at 10% interest. And so then the value of it's $22,044. So it's a 2-step process. And then that single amount of $2,000, we can just move that all the way from year 8 to year 0 in a single step. We don't have to move that to our series year 0 or the quasi-0. We just move it all the way. So that's why we're using n equals 8 when we're doing a P/F calculation. So the combined amount is the contribution from the annual series and the contribution from that single $2,000 payment in year 8. And altogether it's worth $22,977. So that's how we do it when it's an annual series that's been shifted some time into the future, beyond how an annual series usually starts at year 0. We can do a similar thing with gradients. Remember that the pattern of a gradient, if I draw that on the board, our typical pattern for a gradient is that we have year 0, year 1, year 2, 3, and so on. Well, let me also do 4. And so on. All right. So in year 1, we have 0G. Year 2 is G, 2G, 3G. And so here is G, 2G, 3G. And so we need to see the first evidence of this increasing amount in year 2 of a arithmetic gradient. So let's take a look at a similar sort of illustration. In this cash flow diagram, we've got two things combined. We've got an annual series and a gradient. You can see that the annual series is going to be easy for us to take to year 0 because that constant $60 that's every year through year 10, it begins in year 1. So we can just move the annual series all the way to year 0 in a single step. It won't have to be a 2-step process. But the first evidence we have of the increasing $5 each time is in year 4. And the typical pattern, the first time you'd see it is year 2. So we're going to have to do the same thing in coming up with gradient years. This is like our different viewpoint for when time is labeled. And so you can see that this is labeled as, we're going to start calling year 2, we're going to call it year 0. But just from the perspective of that gradient amount of an increase of $5 each year. And so we've relabeled this axis with the gradient years. And so first find the P2, so find the value in year 2 of the gradient and the base amount of the 60. So this is saying you can find the value in year 2 of the gradient. And so P/G for 12% interest in 8 years, we're saying we've got 8 times from year 2 to year 10, n equals 8. So that's why we're using this n equals 8, 12% interest, and we're trying to find the present value of the gradient. Now, the amount of the gradient is 5. So that's going to take all of the value of the gradient to year 2. And then this is also saying, let's break up the cash flow diagram like this. Let me draw it on the board here. So we've got, here's your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. So the 60 is every year. Sometimes these can be really repetitive. That's why the spreadsheets are useful. And then we see the first extra $5 in year 4. So here's 5, 10, 15, 20, 25, 30, 35. All right. So what this is saying is let's take everything. Here is our new quasi-zero. We're going to call this 0. So take the annual series, years 3 through 10, to year 2, and then also take the gradient to year 2. And so n equals 8 because we're taking these 8 payments, 1, 2, 3, 4, 5, 6, 7, 8. So all of it is going to be going to year 2. Then we're moving that dashed line from year 2 to year 0. And then so we've moved this amount, which was converted from all of this, went into there. Moving this to year 0. And then there's 2 years left over that also have to be moved to year 0. So then this is saying 2 years, 12%, and we're finding the present value of an annual series. There's more than one right way to do these. I could have taken the entire annual series all at once to year 0, and then just moved only the gradient to year 2. This is illustrating that you could combine the annual series and the gradient, moving it to year 2, and then moving them combined to year 0. So there's not just one right solution for these. No, we're moving it from year 2. Why? Yeah. So you're saying why is this year 0? I couldn't hear you. All the squeaky chairs. So yeah, why are we moving all of this? Okay. Right. Yeah, because this is 0G, this is 1G, and so the first time we actually see that extra $5 is in year 4. Exactly. All right. So here's the first question on your in-class exercise. If you don't have a copy of that paper, it's here up front. What you're going to have to do is move an annual series to year 0, and then the second part of the graph here, years 7 through 10, is an annual series and a gradient. So following the same kind of ideas that have just been illustrated, we're going to move all this to year 0. Now, on the handout, I'm telling you that the interest rate for this problem is 8%. And so the 8% table is there at the bottom. We're not using Excel for this one. I'd like you to do step by step, summarize what you're moving where, and then let's see if you can get the present value of the entire cash flow at year 0. Okay, I've put the solution on the screen if you want to see how what you're doing stacks up with the approach that I took. Now, I'll repeat what I said earlier. There's more than one right way to solve this problem. There's not just one correct route to the right answer. So in the end, if you get the right number, then that's great. I'll just explain what I did. So I broke it up into pieces and steps. The first step was I took the, the 11,000 annual series to year 1. So there were 3 payments. 8% interest, so I did P/A at those and looked up the factor. So you're moving the 11,000, 3 payments of it to year 1, and then in my second step, what I say here, step 2, I'm moving it from year 1 to year 0. And so then the inflows, the sum of all the inflows, those 3 $11,000 payments, in present terms is worth $26,247 today. Any questions about the first stuff? The inflows, those lines that are up? Okay, maybe the next one's a little bit more tricky because it's got a gradient. Let me scroll down. I'll actually zoom out so we can still see the cash flow diagram. All right. So I started with the annual series, the 5,000 each time, and we've got 1, 2, 3, 4 payments. So n equals 4, 8% interest, and we want to find the present given an annual series, so P/A. So I found the value of that annual component in year 4, and then moved it from, once I combined it with the gradient value, to year 0. So any questions about the solution? Yeah. Why did I move the gradient to year 6? All right. So the first time we see the extra 1,000 is in year 8, right? And so the first time you see the gradient, then the 0 year is 2 years prior to that. And so 2 years prior to, see where we saw the 6,000, if we go back 2 years, then that's year 6. That's just the pattern of a gradient, is that you first see the extra amount at year 2. And so the year 0 is 2 prior to that. Are there other questions about the solution? I think you'll notice that one of your homework problems is very similar. So it'll be to your benefit to understand the process. Okay, so the second part of what we're doing today is back to Excel. I want to reinforce what we were doing with future values yesterday. Not yesterday, last time we met, so Tuesday. So here's the second question. We've got a cash flow diagram, and we want to find out what's the value of all this if we move it to year 16. So you should use the FV function in Excel, and remember that you're going to have 2 different time columns. Guys, quit talking. There will be 2 different time columns. There will be one that is year, and then there will be another time column that is how many years until the time that you're supposed to be taking the amounts to. So here you're trying to take all these amounts to year 16, and so remember the secondary time column, same as we did last time. All right. So all right, let's review the things that students most usually, like the most common mistake, just so that you never make it. The most common mistake when you do equals FV, rate, usually that's fine, but remember you need to anchor the rate. So that means anchoring is when you click on a cell, you put the dollar signs instead of its in front of its location, B3. So you can type those in manually, or if you press F4, it adds them for you. So that means when you drag it down, it's always looking at the same spot for I. So that's a must. Now N, another mistake would be if you just did years. So if you did that, if you clicked on year, then it would think that you should move the 3,500 0 years. But if you look at the cash flow diagram, the 3,500 is moving 16 years because it's going from 0 all the way to 16. So that's why we have this secondary time column here, is just so that our N is the number of years that the amount has to move, not what year it is in. So here we'll click on the years until year 16 because that's how many years we're compounding it into the future. We skipped the PMT field with a double comma because this 3,500 isn't a recurring payment of always 3,500. There's just one amount of 3,500. So we're treating it like it's a present value, not like it's a payment. And then finally, we have to put the negative sign because the FE function always changes positives to negative and negative to positives. We don't want it to do that, so we're canceling out its tendency to switch the sign by manually putting in that negative there. So if we move negative 3,500, compound it 16 years in the future, then it should be, let me change that back to number, negative 9,232. So we can just drag that formula down. Oh, by the way, besides dragging, there's another way that's even simpler. You can drag like that, or you can just double click. If you've got a formula here, you just double click and then it pastes it through as long as there's data for it to paste the formula. And then the total amount at year 16 is what we're trying to find. So we use the sum function for that. And the answer you're looking for is 61,157. All right. Future value. Any questions on how to do that? Okay. That's all I've got for you today, so let's conclude by looking at the announcements again. The homework assignment is due on Sunday. We're back in our normal classroom on Sunday.